All right, guys, so today's lesson is going to just be on the power of the discriminant. Because what we've been doing is dealing with quadratics, being able to graph from vertex form, going back to Unit 8. Well, when we're in standard form, we have to know how to graph, and we have to find out how to solve for x-intercepts when they're in standard form. So we're going to talk about the power of the discriminant, which will lead to the quadratic formula. And this is where we're going to basically end this school year with these two concepts. So with that, the discriminant in mathematics is a function of the coefficients of a polynomial equation who gives information about the roots of the polynomial, roots being x-intercepts. So coming down to part C, okay, these are your notes. What other words are used for the word root? Well, we know that words such as, let's see here, for roots, we use words such as x-intercepts, solutions, the zeros of the function. Okay, so these are some of the other words that we use to indicate root. So going on, it says, read the boxed explanation of the discriminant below. What do you think it means by number and nature of the solutions? In the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, the expression under the radical is called the discriminant. So the b squared minus 4ac is all we're going to focus on today. The value of the discriminant determines the number and nature of the solutions of the quadratic equation. Solutions, again, meaning the number and nature of the x-intercepts. So our options are none, 1, or 2. Okay, Alexa, music off. To better understand the number and nature of the solutions, we'll look at a few examples. All right, so determine the discriminant for the equations below. So the discriminant, again, we're going to be using is b squared minus 4ac. So b squared minus the product of 4ac. So the first thing that we want to do is we're going to look at this first example. We're going to identify a, b, and c. Well, in this case, let's also look back to ax squared plus bx plus c. So know that your a is just the coefficient of x squared, b is the coefficient of x to the first, and c is just your constant. Okay, so in this example, notice that it's x squared plus 0x minus 1. So your a is the coefficient of x squared, which is 1. Your b is 0, since there's no bx, and your c is a negative 1. All right, so now we're going to use a discriminant. We're going to go b squared minus 4ac. So I always like to do this. B squared minus 4 times a times c. All right, so b is 0. A is 1, and c is a negative 1. Okay, so now we simplify. Well, you always evaluate exponents first, but 0 times 0 is just 0. So here's the thing. When you're simplifying the back end of this, see this is a negative 4 times 1 times a negative 1. So I always like to simplify the signs first because that's really what's going to tell you how many roots you have. So a negative times a positive is a negative. And then we have another negative, which makes it positive. So what you're really looking at is a negative times a negative, since the middle term is positive. A negative times a negative is positive. So 4 times 1 is 4 times 1 is 4. So you get a positive 4 as your discriminant. So the number of solutions, well, looking here in the graph, you see that you have 2 x-intercepts. Because this is a positive 4, because it's positive, that tells me that there are 2 real roots. And that's because the 4 is positive. It could be any positive number, but because it's positive, any number, that tells me there's 2 real roots. So again, how do I know that this has 2 real roots? Not because it's a 4, but because it's a positive number. All right, let's take a look at the next example. In this example, you could see that the x-intercept there is no x-intercept. So let's see what kind of discriminant we get in comparison to where there was 2. A positive discriminant versus another discriminant. Let's see what kind of discriminant would give us no x-intercept. So here you have A is 1, B is a negative 2, and your constant is a positive 2, your C. All right, so now we're going to do the same thing. We're going to go B squared minus 4 times A times C. All right, so your B is a negative 2. Your A is 1 and your C is 2. So again, we're going to go ahead and evaluate a negative 2 times a negative 2 is a positive 4. And remember, I like to multiply all of these at the same time. Since there's only one negative number, you know this is going to be a minus. And now we're going to multiply 4 times 1, which is 4, times 2, which is 8. So 4 times 1 is 4, times 2 is 8. So 4 minus 8 gives me a negative 4. Now, because my discriminant is negative, that tells me that there are no real roots. Okay, which means there is no x-intercept, there are no solutions. All right, so when you simplify b squared minus 4ac and it gives you a positive number, that means there's 2 real roots. We've now seen that if you have a negative discriminant, here we simplify this and got a negative number. A negative number tells me that there are no real roots. My parabola will never touch the x-axis. All right, so now finally, let's look at this last example. Here's your x-axis. Notice that there is only one x-intercept, and that is at the vertex. So let's see what type of discriminant will yield one x-intercept. Okay, so far we've seen a positive discriminant. We've seen a negative discriminant. Let's see what this is going to look like. So A is 1, B is a negative 2, and C is a positive 1. So we're going to go B squared minus 4 times A times C. Now B is a negative 2, A is a positive 1, and C is a positive 1. Again, remember, we evaluate that with the signs first. So, all right. Let's go ahead and evaluate negative 2 squared. A negative 2 times a negative 2 is a positive 4. Now, we only have one negative in all of these 3 numbers, so that means this is going to be a negative. And 4 times 1 times 1 is just 4. So 4 minus 4 yields a 0 value. Okay, so that tells me when your discriminant is equal to 0, that means that there is one real root, and we could see that here on the graph. Okay, there's one real root, and that one real root is at positive 1. Okay, so just to do a little recap, when your discriminant is positive, we have 2 real roots. Any positive number, 2 real roots. When your discriminant is negative, that means you have no real roots. Your parabola will never touch the x-axis. Finally, Here we solved the discriminant and it gave us a 0. So whenever you simplify the discriminant and you get a 0, that means you're going to have one real root and it will always be at the vertex, which means the 1x intercept. All right, so let's go ahead and switch down to this example down here. Now we're just going to talk this through again. All right, so looking at this graph, okay, because there's one x-intercept, one real root, that means that b squared minus 4ac, if I were to plug into all those variables, it would give me, test yourself, would it be a negative? Would it be a positive? Would it be a 0? Because it's one real root, if you look back over here, one real root means that I would simplify b squared minus 4ac and get a 0. So down here, b squared minus 4ac is going to be a 0. That would be the nature of this root because there's only one x-intercept right here. All right, let's look at the next one and compare it. Well, here, there are no x-intercepts. So that means that b squared minus 4ac, if I were to plug it in, it would give me a negative number. A negative number, okay? So a negative number would tell me that there are no x-intercepts. And looking at this last example, you'll see here that there's 1, 2 x-intercepts. So that means that b squared minus 4ac would equal a positive number, any positive number. That tells me that there are 2 real roots. Okay? All right, so practice finding the discriminant. We're going to go ahead and do a couple of these. Okay? All right, so let's do numbers 10, 11, 12, and 13, and that'll be sufficient for our notes for today. And then what I want you to do for your practice on this is you're going to go on to Delta Math and complete the power of the discriminant as practice. All right, so first things first. In all of these, if you notice, everything's equal to 0. So, I'm sorry, you have to set everything equal to 0 first. So step 1, make sure everything is equal to 0. So I'm going to combine like terms. I'm going to move the constant to the left and the negative 3p also to the left to get it equal to 0. So I'm going to go ahead and subtract 8 from each side and lining up my terms as I go. I'm going to add 3p so that these cancel out. But what I do to one side, I have to do to the other. All right, so I bring down the p squared. 7 plus 3 is 10p. And then 33 minus 8 gives you the positive 25. Okay, now notice that your quadratic formula, the standard form of your quadratic formula is equal to 0. So now what we're going to do is just so it says determine the number of real solutions for each quadratic equation without solving. Okay, notice that the variable does not need to be x. So again, what I mean by this is when you do your practice for this assignment also, just make sure that everything is equal to 0. All right, so here we go. So I'm going to go ahead and go A equals 1, B equals 10, and C equals 25. All right, so we're going to go B squared minus 4 times A times C. All right, so B is 10, A is 1, and C is 25. All right, so 10 times 10 is 100. Then remember, I like to scoop in all 3. Because there's only one negative, that means it's going to yield a negative. So 4 times 1 is 4. 4 times 25 is 100. So 100 minus 100 is 0. So because the discriminant is equal to 0, that tells me that there is one real root, and this is your final answer. So when they say explain the nature of the root without solving, it means use the discriminant b squared minus 4ac to tell me how many roots exist, if any at all. So you're not telling me what they are, what the x-intercepts are. You don't have to go that far today. That's going to be next Tuesday's assignment. Okay, today we're just going to determine if it's a positive, a negative, or a 0, and if any roots exist. So that's the goal for today. All right, number 11. All right, so it's equal to 0. Yay, us. So A is 7, B is 2, and C is 5. So we get B, well, let me go ahead and make sure I'm writing out the formula. B squared minus 4 times A times C. So it's going to be B squared minus 4 times A times C. So B is a positive 2. A is a positive 7. And C is a positive 5. So again, we always start with exponents. 2 squared is 4. Now I gather all that up, swoop it up, and there's only one negative, so it's going to be negative. And then we're going to go ahead and multiply 4 times 7, which is 28. And then we're going to multiply that by 5 to get 140. Okay, so 4 minus 140 is a negative 136. Because this is negative, you know that there are no real roots. So this is how later on you'll be showing work. All right. So again, your practice for this is going to be on Delta Math. And for Delta Math, it says finding the quadratic discriminant. Finding the quadratic discriminant is what you're going to be working on. And solving for those, the discriminant to determine the nature of the roots. Sorry, I was pulling up Delta Math right now to make sure everything looks good. And it's all there. All right, here we go, number 12. Let's see here. So again, I need to get isolate everything. So there's that term, there's this term, and then there's no constant. So we'll go ahead and start by combining like terms, but I have to use my algebraic properties. So I'm going to go ahead and subtract y squared, and what I do to one side, I do to the other. Okay, and at the same time, I'm going to move the positive 4, so that would be a negative 4y. Okay, so these are all canceling out. So now I'm going to simplify. So 2y take away 1y squared leaves me with y squared. 10 minus 4 is a positive 6y. And now I'm going to go ahead and add 3 to both sides. So this is going to be plus 3 to equal 0. All right, so now we have A equals 1, B equals 6, and C equals 3. Please make sure you're filling in these notes so that you can utilize them when you're working on Delta Math. All right, so here we go. We're going to go B squared minus 4 times A times C. So your B is 6, your A is 1, and your C is 3. All right, so 6 times 6 is 36. And there's only one negative here, so it's going to remain negative. So 4 times 1 is 4, times 3 is 12. All right, so 36 minus 12 gives us 24, and it's a positive 24. So because this is positive, because the discriminant is positive, we know that there's going to be 2 real roots. All right. All right, so at this time, why don't you guys go ahead and give this a quick pause, and you try number 13, and then come back to check to see if you got it correct. Okay, so hopefully you've paused and you've tried the problem. So now you can check your work. So again, I need to get everything equal to 0. So I'm going to add 4z to both sides. and 4z squared comes down. Now remember, there's no other 4z or z to the power of 1, so this is just positive 4z plus 9, and now I could set it equal to 0. So your A is 4, your B is 4, and your C is 9. So we're going to go B squared minus 4 times A times C. So your B is a positive 4, your A is a positive 4, and your C is a positive 9. So we get 4 squared, which is 16. And now, again, we only have one negative, so this is going to be negative. Okay, 4 times 4 is 16, and then 16 times 9 is 144. Okay, now 16 minus 144 leaves us with a negative 128. Because this is negative, because the discriminant is negative, we know that no real roots exist. All right, so again, you guys are going to go on to Delta Math, and you're going to complete the assignment, which reads, finding the quadratic discriminant. Okay. Again, if you want to do that with me online tomorrow, Tuesday rather, sorry, 5/12, I'll be available for that as well. All right, guys, this concludes the notes for this week.